Hi there, welcome back. I've got some progress. I received in the mail the order from Doornberg Electronics in Ireland. This is in Renefast, County Donegal, where they supplied me with the transistors that I needed. Great stuff. It's always great when you get components. Now, what I needed specifically, I needed these AC153s as the power transistors. I actually bought more than these, and you'll see why in a second. I've got some AC126s, AC151s, AF124s, and AF106s. Now, these are the transistors that I think will probably need to be replaced, and I've done some replacing. Let me show you. You recall this was all a bit of a mess with all the wiring. It's still there. There's actually a bit more than that now. I'll show you in a second. But these are the two transistors. I replaced those PNP silicons with the AF or AC153Ks. You've got to be careful with the pinouts on these things. There are two versions of the AC153s. These K versions are the ones that I ordered. That's the ones they call for. It's got a sort of a heat sink on there, which I presume makes them more suitable for power applications like this one, although it is low power anyway. But what I did then is I just put in the colored heat shrink to try and avoid messing things up and getting it the wrong way. The protocol, if I understand it correctly, going from these guys over here, is that the collector is red, the base is green, and the emitter is yellow. And it sort of makes sense because these are PNPs, so the collectors are usually going to be connected to the power supply rail, the positive supply. I'm not sure if this is a definite protocol, but I followed the same example on here. They obviously came with nothing on there. So these were put in, and something else has been changed. The Zener diode, which I thought was a Zener diode, which is this guy over here. This is a 2.8 ST10, and I thought it was a Zener. I understood the function of it on the circuit. It was supposed to drop what I thought should be 2.8 volts, and I just assumed it was 2.8 volts, but I took it out anyway. I put a 15K resistor on here. Now the reason I put a 15K resistor on here was because that's what it is in the circuit. It's biased with this point, this point going to 12 volts, this point going to the resistor. It's the other way around, but there's a resistor in series, and this thing is set between 0 and 12 volts. And I measured the diode drop, the voltage drop across that. And what it gives me is 2.1, 2.2 volts, which is a bit low, because I do believe that 2.8 is the voltage drop. So what I think this is, it's pretty similar to a bunch of diodes, or an arrangement of diodes I saw on the H.H. Scott project that I did, where they use 4 diodes in an array to get a 4-volt diode drop. And the idea is those things are actually linked to the heatsink, so the temperature coefficients will compensate for the same thing happening on the transistors. But I think in this case, it's basically just to get 2.8 volt drop. Now, I thought it was a Zener, but it's not, because if I measure the reverse voltage across here with the diode tester, if it was a Zener, I should get a normal diode drop, which I don't. So these are actually forward biased diodes, 4 diodes in series effectively. And because this wasn't giving me 2.8, and from the measurements I've done, the other one is even worse. What I did is I decided to rebuild this, and I used 4 1N4148s. The amount of current going through is very, very small. So 1N4148s are fine, and I put 4 of them in series, solder them in, measure the diode drop, and it comes out as near as damn at 2.8 volts. So it is giving me, at this current, remember this 1.5K resistor is determining the current that's flowing through them to give us a steady diode drop or voltage drop, and I measured 2.8 volts exactly. So I used those, I put them in some heat shrink, They're soldered, they're stuck together. I don't think temperature is an issue here. So it's not stuck to a heatsink or anything like that. It's just to get the diode drop. So I replaced that in the bias circuit. And then I went and did the test again. So when I did the test, I got some completely different bias current. I started at about 4 volts instead of 12. And this thing was going quite high. And that makes sense because this was biased for 0.6 or 0.7 volts silicon transistor breakdown or conduction. So I started very slow and I started adjusting the pot. And I'll show you what we get now. I'll put on the power supply, supply it with, I believe I can now do 12 volts. And see what we get. I've got a 200 milliamp limit just in case. 8.8 and it's climbing. And it does climb for a while. I'm obviously measuring the bias current on that link that you're supposed to break. It's the link that connects the transformer, the center taps to ground. And this thing will settle at about 10.5 volts, milliamps, which is fine. They have a link, a breakage in the circuit, which I showed you before, and that basically tells you or measures the current flowing through the output transistors, which will be the quiescent current. There's actually another way you can measure this, which is quite easy. There's a 1 ohm resistor in the circuit that's actually supplying the emitters of those two transistors. And you could just as easily measure the voltage drop across the 1 ohm resistor, and that would give you the same reading. It's 1 ohm. If you measure the voltage drop, you should get 10 millivolts. Well, in this case, you'd get 9.36 millivolts. And I'll show you, actually. We can test that with Big Brother. So now I'm putting this across the 1 ohm resistor over here. I've just found a mistake. Let me put off the power and put this on resistance. I've got a 10 ohm resistor on there. Now that ain't right. It's supposed to be a 1 ohm resistor. Okay. Well, that was useful. Found a mistake. I've got to replace that resistor. Huh. Okay, well, while we're talking about stupid mistakes, let me tell you about another one that I made when describing the circuit. This is confession time. If you recall, I described the operation of this output transformer here. And there's a real stupid mistake I made in describing the circuit. I said that this center tap here, which is connected to ground, was part of the secondary circuit. It's not part of the secondary circuit at all. It is, in fact, part of the primary side of the transformer. The secondary circuit is one winding that goes from there, through there, and out there. And there's no center tap. This center tap is on the primary. In other words, this transistor here sees a load, which is this winding here up to the center, to ground. Okay? Positive supply there, going into the emitter through that, what should be 1 ohm resistor, right? So you've got basically 12 volts over here. And this is your load. It's pushing the load through to ground. Now that makes sense. And the reason I made a mistake is that this drawing is rather weird. It doesn't follow the convention that that one there does. You see, that one makes sense. You can see the primary, you can see the secondary. This one is drawn like this, which is a bit strange. And that's where my mistake came in. So this transistor is pushing whatever signal's coming in here. It's actually feeding it through the load, which is half of that transistor, one winding of that transistor, to ground. This one is pushing the same thing through that half of that transformer, to ground. And that's where you get the push-pull action. And that's why you're getting a push-pull situation here. And your signal is now double, or the combination of the push and the pull, pushing in different directions. I gave an example to someone who commented, and it was a very good comment because he was also a little bit confused by the way I described this. And I must admit, I didn't give it enough thought, and I apologize for that. He couldn't figure out how this worked. And I said, it's like, this one's like an elastic. Imagine an elastic where this one's pulling up and that's pulling down. You put an elastic between your fingers and you sort of pull your fingers away from each other, you know, sort of. And that sort of describes what's going on here. Not exactly. But now it makes more sense that you've got your secondary in one winding. And these two are pushing loads or feeding loads which are half of the transformer primary. Right, that confession out of the way. What we've got here is one error on that 1 ohm resistor. I'm not sure that it's going to change the bias. I'm going to change that and see what happens. I don't think it'll actually affect the bias because that 1 ohm resistor over here is just acting as an emitter resistor to these transistors and basically helping, well, I guess avoiding short circuits if I'm not mistaken, or helping with thermal runaway. Yeah, that's probably more what it's doing. These things are prone to thermal runaway. Germaniums, they do react more to heat, and you can see that. If you measure the diode drop across here and you just hold it, it changes quite rapidly actually. So if you have that, what happens is that as this thing starts conducting more current, if it gets hot, it starts conducting more current, it'll pull more current through that guy, and the voltage drop across this guy increases. So the voltage that gets to those emitters, what happens? It's 12 minus this voltage drop, and that decreases. So that should reduce the current flowing through there. That's sort of a negative feedback arrangement. It's a local feedback arrangement where the more current these pass, the less voltage will appear here, which makes them conduct less current, because that resistor voltage, the voltage drop across that resistor, will increase with an increase in current. Hope that makes sense. Okay, another question that was raised was this guy over here. I said these were variable resistors. They're absolutely not variable resistors, as various people pointed out. They are thermistors, or sort of thermistors. Basically, they are there to they are a thermal compensation for this part of the circuit. So if I drop this resistor, this 100 ohm, if I make this smaller, the bias voltage here will also drop. In other words, these things will be cut off slightly. So the more current flowing through there, the hotter this gets. The hotter this gets, in this case, it'll stay exactly the same. But if I have a thermistor here that drops the resistance, as it is now, I would have 120 ohm in parallel with the 100 ohm. So it'll be about, 50 something ohms. But if this thing drops to say 30, or say this thing drops to 60 ohms, then I'm left with about 20 ohms, and this voltage is affected and the bias of that thing drops, so the bias current drops. So again, it works as a local feedback to prevent thermal runaway. The problem is I can't find these guys. I don't even know if they make them anymore, but I did try a thermistor, and I'm waiting for 100 ohm thermistors or 120 ohm thermistors. I've got a 1K, which is the lowest I've been able to find, but I will get the right one there. At the moment, I'm biasing it with this, and when I get that, I'll put it in and I can adjust this bias again, because this one is actually available through the circuit board, through a hole in the back. You can actually adjust it through a hole in the back, which again makes sense that you'd have a break on the board here. That break that we desolder and solder again is over here, because it's measuring this current going through here, through there, and back to ground. So that's it. That basically explains that part. But I do have some good news, and that is that I've got that part of the circuit working, and I've actually gone a little bit further. Let me show you. You'll probably recall this mess of wires that was going up here over the top. Well, there were more wires that needed to be sorted out, and quite frankly I had no idea where these other wires went, so I had to track them, and I did some experimentation. And this red one here, this is the audio, and what it has is it has the signal coming through, the output coming through on the red wire, the center wire. This cat really wants to be seen, boy. This cat is really looking for some fame. The screen of that is actually the positive supply, which is acting as a shield. And the other one, which is stuck to an orange one, is actually the feedback, which comes from that first transistor. And what I did is, once I found or identified what they were, I sort of took them and wired them with an extension wire to the board. Where is it? Over there, I think. And this allows me to test the entire system with, if you recall, I already had the speaker output over here, but now I can test the actual connections over here to the volume pot and to the tone control, which will affect whatever I put in. And I can put in either one of the radio signals, which I have not connected yet, but I can also put in the phono. And that's that selection, third from the bottom over there. That's phono input. And this here is the phono input. So I've wired this DIN plug as an input to the phono in, or mic in. And now we can actually test it. We can connect the signal generator to that phono in, and we can actually have control over it with the volume control and the tone control, which is good because we're going to test it in a second. So we're ready for the test, and what we're testing is the audio amplifier stage and also the input switching and volume control and tone control. Now I've got to advise you, this is all a little bit, well, rather messy in the way I've wired it, but this is all temporary because I then want to put it in and do it properly. But here we go. We've got a 1 kilohertz signal coming into the phono input here. I've selected phono at the bottom in the input selector, so the phono input is switching through, should be. It's going in and going through all the pots, or the pot and the tone control arrangement, and then it comes out of here from the switching, and it goes into the amp, into the amp board's input. The amp board's output then sends a signal through to the speaker terminals here. And what I've got is I've got the internal speaker connectors wired to the dummy load at 4 ohms. Now let's look at the scope. I've turned on the signal generator and the power. I still have about 8.5 milliamps going through as the quiescent current because it's still sort of warming up. I've just switched it on. And now I'm going to turn up the volume control. And it's difficult because I don't have a knob, and I'm touching the wires, but there we go. There's the volume control. And the tone control, you should see a little bit of an effect, not much, because this is at 1 kilohertz. I've just touched something, yeah. But there we go. We've got all that oscillation is normal because I've got all these wires sort of hanging around and I'm touching them as I go along. But it looks like our output's working well, as is all the input switching, at least where it's switching the phono input in. So it looks like we've got all this, the audio wires connected properly. This board does, however, have a little bit more work that needs doing. I've now got the board, and I have to remove these wires, or the ammeter, and I have to reconnect that jumper joint over there. In other words, put these two together. I'm actually going to just solder across there. I'm fairly happy that that I've got the right bias. Actually, no, I need to do something else first. I need to change this resistor to a 1 ohm and check the bias again. Damn. Okay, let me get that done. Okay, we try that again. I've got the power supply set I've changed that resistor to 1 ohm, and I have to adjust the bias again to 10 milliamps. That's close enough. It'll go up a little bit as it stabilizes. Actually going to go up a bit more than I wanted. Leave it there and it'll probably creep up. So we've got 9.5 milliamp quiescent current, and now we're going to do the audio check again. I've set this up with the iPad as the signal generator. I'm using the EE app, EE Toolbox app, 1 kilohertz sine wave, and the reason I'm doing that is the signal generator itself has referenced to earth, mains earth, and because I've got the speakers, that speaker wire connected to there, and I want to see the signal on the scope, I'm effectively shorting the output, the speaker to earth as well. So I don't want to have two earth references or mains earth references. So in this way, because the power supply is completely isolated, the signal generator is now completely, or the signal source is completely isolated. The only mains earth reference is the oscilloscope, which shouldn't cause any problems. So at the moment, it's crept up to 10.4 milliamps. Let me connect the signal and see what we get on the scope. Okay, I'm going to hit the signal. And now I'm going to adjust the volume control. Obviously, I'm watching the load current. It's gone up to about 45 milliamps, but that's normal because I'm obviously running it now. And I'm going up. I want to see where it clips, and it starts clipping there. 2 volts RMS. Now obviously this thing could change somewhat when I change the input transistors. I haven't swapped those out yet, and I guess that's what I'll do next and see if it makes any difference to the output signal. Okay, just a quick update. I actually swapped out these 2 transistors, and the bias went a bit funny, and that's normal because there's actually a resistor here that's indicated as variable. And what I found is that the actual voltages that you're supposed to get on here, they give you 2 voltages. They give you that voltage there across that resistor, that 56 or 5.6K resistor, 3.2 volts. I get about 3.1. Now that is obviously affected by that resistor there, the voltage at that point, which is affected by the bias of this transistor. And they give you another voltage here, which says 6.5, or is it 8.5? Anyway, I get 7 point something here. It's between the positive 12 volts and the negative of the capacitor that we have there. And so this resistor here is a variable. It says between 20 and 40 ohms. I believe they've got, what have they got here? They've got, can't see it actually. It actually looks like 12 ohms. Anyway, that is adjusted. You adjust that resistor to create that bias point over here, which is that voltage across there. Now they seem to be fine as they are. So I'm leaving these 2 transistors in place until further notice. I'm not detecting any problem with the audio, at least on the scope. So I think that part of it is done. Now the part that I need to pay a bit of attention to is this part over here. And what this does is, if we look at the voltage coming in here, that is just the 12 volts. Now what happens is 12 volts comes in here. There's a bias set up over here, 10K and 220 ohms. That creates the emitter voltage over here. That emitter voltage in turn, well, let's go the other way and look at the typical bias. I always get confused with these PNPs because the bloody polarities are actually reversed. What we have here is another one of those diodes, the 2.8 ST10. And the value, the voltage drop on that particular diode, that one there, is completely wrong. So what I'm going to do is I'm going to replace this diode also with 4 1N4148s. That is biased from 12 volts to ground, the new ground. This is now the new ground. Well, this is actually chassis ground because it connects there to chassis ground. If you remember, the other ground was actually the 0 volts on the 12 volt rail. It's a bit confusing, but it makes sense. So as far as chassis ground is concerned, you've got about 11 point something volts over there. There's a bit of a drop across this resistor, so there's about 11 point something volts, and that biases, that 4.3K resistor biases that. So you get a 2.8 volt drop below that point. And that is confusing too, because it actually says, oh, it doesn't, no, don't worry, 2.8 volts over here, that stays as the common. So they say you should get 1.5 volts across there. Now, why would you get 1.5 volts across there if you have 2.8 volts across here? Well, you would, because you've got this resistor here, 1.5K resistor, which when current is drawn into that circuit over here, it creates a voltage drop across the 1.5K resistor. So the 2.8 minus the voltage drop across here would give you a 1.5 difference over there. I'm getting slightly high voltages, especially down here. This is what I'm getting to, this part over here. Because testing this thing over here is difficult because we don't have a load. This thing is going off to wherever, 11. I think it's going off to the IF amplifier of one of the bands, whether it's FM or AM. So we don't have any current draw at the moment. So I would expect this difference to be practically the same as that difference there without a load. So 2.8 volts difference. So we'd get about 11.5, say, or 11 volts, and minus 2.8. So 8 point some, 7 point something volts over there. Okay, but that's not the part that's worrying me. The part that is concerning me is that this voltage here, which is the one that's regulated, set by this pass transistor, should be this voltage created, the bias voltage created over here by this diode array, and also by the voltage that you create over here. And they actually do say in one of the manuals you can put a 10K pot to adjust this perfectly to get the 5.5 over here on FM and 5.7 on AM. At the moment I'm getting this a little bit high, so this resistor, this transistor might be the problem, but my guess is that it's that guy over there. So I'm going to change that guy over there and see what we get. Here we have that other diode array. I've got 12 volts coming in here. The positive of the multimeter is connected on there. I've got the multimeter effectively connected across the diode array. And then the ground, or the 0 volts, goes to the other end of that resistor. I've got a 4.7 ohm K resistor in there. And strangely enough, when I first put this on, I was getting 5.7 volts. And now it's giving me closer to the 2.8 that I'm supposed to get. There's something definitely wrong with this, because it is jumping all over the place. If you looked at this and said, okay, that's a 2.8 volt array, it's giving me 3 volts, yeah, not bad. But it started off at 5 point something, so there's definitely something wrong with those diodes. And I'm going to replace that with 4 1N4148s as I did the other one. Well, folks, I did it again. I went and lost a heck of a lot of footage, which, since this is footage that I took as I was doing quite a bit of the progress on the radio, I can't redo. So I'm going to have to describe to you what it was that I did. And I hope I get it all. Let's start. First things first, I neatened up, or actually just threaded those wires, all the loose wires that were coming from the bottom here. Passed up to the top here. through that holder there and into the area where they should be. And what I did is I left them a little bit longer than I needed and just made sure everything fit properly. I had to make sure that this thing closed without snapping any wires. I've only put 2 screws on this switchboard so that I can flip it out if I need to. So that was step 1. If that was step 1, step 0 was cleaning up the board. I removed all the wires that were there temporarily, cleaned the solder off their connections so that they were ready for the next stage of soldering on. This happened on both sides. The board was cleaned on the top and bottom as best as it could be. And the result was actually pretty good, as you can see from the photos I'm showing here. The wires that came through from the bottom were then trimmed to a size that would allow me to flex them around quite a bit and soldered in there, and of course on the other side as well. The other wires, the wires on the underside, which I don't know if we're going to be able to see. Actually we're not. But what I did was actually we can, sort of. I extended them a little bit, so we had some length. If you recall, some of them were very short and untidy. I put some more heat shrink on there in the appropriate colors, and then I also extended the heat shrink on the red and the yellow guides or tubing that was short, so they came through with a little bit more length. We didn't have to worry about pulling them taut. Never a good idea. So that was put in there, and then this board was then connected, or rather screwed onto its place. The one contact here, this one there, is actually a ground. It's the Z connection. That screw I put in a washer underneath to make sure we get good contact to the chassis. That is effectively chassis ground. 2 of the wires, or one of the wires coming from below, was that brown one, which actually went to the DC jack socket, and the black one, which is connected to there, that also went to the DC socket. I've sort of twirled them around that spacer to make sure that it can't be pulled. And then using a drill with these 2 wires, you create this sort of braid effect. And I've soldered it onto this socket. And the reason is this socket can actually go in from the back and then screw onto the back plate. I don't have to desolder it if I want to remove it like I had to do the other one. This makes it a lot easier. I think I've given it enough length so we don't have a problem with the back cover coming on. What else have I done? Oh, I removed the antenna just to make it easier to handle all this. And let's look at the other side. Well, basically this is what it looks like. As it is, it's sort of ready to go into the box, into the chassis if it was working. So now we need to do the final test with this thing sort of stabilized, as it were. You can sort of see where those wires go in there, where I've actually lengthened them somewhat, just to make it easier to solder and actually to move the board out if I need to. So now it's a question of setting it up to test. Time for that. I think we're about ready. I've got the iPad in here as the signal source again. I've got the speaker connected, or it's connected to the dummy load with speaker. Let me give a dummy 4 ohms. That's connected to the scope. The only earth ground is through the chassis, through the oscilloscope. That's off, that's line. That is off, actually. I think that's working. That is on. It's drawing 20 milliamps from the supply at 12 volts. I've got the phono selected, and now signal generator is going. Let's see what happens. Yes, can you see that? There we go. And it's clipping uniformly at 2.2 volts RMS. 2.2 volts RMS. So 2.2, that's 4 at 4 ohms. It's sort of 1 watt, I think it is. Nothing too dramatic, but it's working. And the one thing I've noticed is, if you, let me give this a bit more volume. This volume pot has got 2 listening levels. There's the one, and if I pull it out, it cuts it down completely, and you still have volume control. In other words, you can still get it that high, but there it'll clip. So you basically create 2 listening levels, depending on whether it's out, the volume pot, or whether you clip it in. And that just adjusts the listening level that you're going to use in the room. And that's it. I think that's brilliant. The signal, well, the amplifier works. That's the phono input. Now, the one thing I've been dying to do, and I was dying to do, and I have to confess to you, I've done it already. You can probably guess, because I've got the knobs on there, right? I mean, would you believe me if I said that I got it to this stage and that I didn't push that button there or that button there to see if we've got any radio? I don't think you would. So I'll tell you, I've done it. And let's do the following. Let's get this on speaker. Get the volume a little bit lower down. And let's push FM. If it would click. Can you hear that? And that, my friends, is with the antennas down. Let me put the antennas up. Putting up the 2 extendable FM antennas. And that is through the external speaker. And it's a bloody good reception. I've got the microphone on my chest and the speakers on the ground, but believe me,
for a long time. I was in that house.
That is pretty good. The sound quality is excellent.
Não podemos deixar de falar do carinho que as pessoas sentem pela Bárbara Tinoco e o facto dela ser muito baixinha.
And if I pull it out, the volume control, it takes it sort of into a speech mode, into a less broad bandwidth mode. Push it back in.
Os fãs do Twitter, aliás. E de resto, acho que são os GIFs habituais.
The tone works well.
A ver ao longo destes anos e a ler.
The other thing it works is the broad and wide and narrow switch. Watch this. Listen to this.
Não, cuecas.
Não, deve ter sido quando saiu do modo.
That becomes more tinny. That's more narrow.
Não era, passa para uma saia.
That becomes more bassy. That's broader. So, sort of voice, music.
Tinha sido qualquer coisa assim, mas as pessoas prestam atenção a detalhes.
Sim, mas o dado a retirar
Damn, I'm happy.
ninguém ficou indiferente ao Filipe
And look
Sá.
what else is working.
Pode ser bom.
São de votos de
I'm going to tune. Look at the
das chamadas
tuning indicator.
ao longo dos como já foi anunciado.
Don't have any stations up here.
Hoje serão comunicados os 4 que passam à final, mas de uma forma completamente.
So that's working too. The other thing I've noticed is working is this, if you recall, I said if you're on FM and you push this in, you get automatic frequency control. And I've noticed that that works too.
Dos 16 que acompanham a edição de 2020, os outros 8
What happens is, if I tune away from it,
nós também vamos cá estar, claro está.
it actually maintains a strong signal.
Estamos a instantes de conhecer
So,
então a votação destes.
That's fantastic. What about AM? So for AM, we need to connect the other antenna. And what I'm going to do is, I have the antenna here. I'm going to open it up and just touch it to the antenna connector. This is a very tall antenna. So let's put it on there. It's touching the connector now. And let's try, what have we got it on? Oh, I need to put this thing on. This thing on, well, I can't change the bands. That's not a good idea. Okay, let's put it on. What is that on? Broadcast band 1, and let's hit AM. And if I'm not mistaken, that brings in the ferrite antenna or not. So let's leave it out for now. And we tune at the top here. Bugger all. Let's try the ferrite. No, bugger all. Broadcast band 2. Ah, we got something. Yeah, we can probably use the narrow band quite effectively. It's getting some reception, not much. What happens if I get rid of that antenna? Well, with the external antenna, with the normal antenna, you get bugger all. I'm actually touching it. That's why it's doing that. Let's try, what is it? Long wave 1. Looks like the switch is not working too well. Absolutely nothing. Let's try the ferrite. Nope. This barrel switch needs cleaning, it seems. Absolutely nothing. Shortwave. I'm fiddling with the switch there to try and get something. Nothing. 2, shortwave 2. I'm not sure that that switch is making contact. Shortwave 3. No. 4. We should hear something if it was working. 5. No. Definitely something wrong with that switch, with the whole barrel thing. Seven, we've got some noise. We've got some hiss. No reception though. Definitely have hiss on there. Shortwave 8. It's trying. If I push it, I can sort of hear a hiss. No. Anyway, that is working. FM is working. The phono input is working. So our input selector switching is working. It seems the AFC and the ferrite antenna select is working. What else do we know? Well, what else do we know? Actually, we know quite a bit. We've got the volume working, tone working, the narrow and broad switch is working, and the one problem we seem to have is we've got no AM. None of the AM bands are working at all, practically. But that is a challenge for another video, if not another day. I think I'm going to cut this video short, wrong term, for now, and do some investigation. And the fact we've got FM working doesn't mean we've got it all working perfectly. We've still got to check all that. But certainly the challenge now is the AM. And since this is a world receiver, obviously AM is very, very important. And I know that the owner of this radio is keeping track of the videos, and he's pretty anxious to hear something come out of it. So I hope that when he sees this video, at least he'll start breathing a bit more easily. Anyway, folks, thanks for watching. It's been a long one, actually, but this has actually gone through quite a lot of progress here. Thanks for watching. Hope you've enjoyed this. If you have, please click like. It does help, and share it. It helps a lot. And subscribe if you haven't subscribed yet. And if you want to support the channel, you can do so on Patreon or on PayPal, and all that information is at the end of the video and also in the description below. Once again, thanks for watching. Bye for now.